Hey guys, welcome back in. Mr. Marone here. You are into lesson 9.3, which is going to be a brand new one for you. This is all about circles, which we have not gotten to yet. That'll be our next chapter. But we're going to look at them in the coordinate plane. So we're going to stick with our coordinate plane theme here. And they've done a really good job in our notes of explaining all of how we graph circles. They are not something you can graph on your graphing calculator. The graphing calculator is designed to only graph functions. And because circles do not pass the vertical line test, they're not considered functions. So they're very difficult to graph. You actually have to do two equations. It's a mess. But we can look at them on a coordinate plane and do a lot of different things with them. So looking at this example here, they've given us a circle, and they've told us that we reference the center as HK. That's the coordinate point for HK. And if we look closely, in order to figure out what our distance between HK and some point on our circle is, that's our radius right there, and we work through it, and it ends up becoming this process of using the distance formula. So we'd use the distance formula, and if I plug in my points here, if I replace my, if I were to replace these with my correct points, I would have x minus h. That would be my horizontal distance, and then I have y minus k as my horizontal distance, and that equals my radius. So if I want to get rid of that square root, I can square both sides, and that's how we get the circle formula. It's x minus h quantity squared plus y minus k quantity squared equals my radius squared. And so if you notice, our h and our k, the signs change because it was originally hk, and now it's negative h, negative k. So just keep that in mind as we look through it. And here's your definition for it. Of any circle, your center is hk, and then your radius is r, and our formula is x minus h squared plus y minus k quantity squared equals radius squared. So if we take a look at this, it says what are the radius and the center of a circle with this equation. So this number right here, that's h, and this number right here, that's k, and this number right here is r squared. So whenever you're given an equation of a circle, you have to flip the signs on h and k. So my center is going to be just 2, 3. You just flip the signs. Whatever the sign is, you flip it, and that's your actual number pulling it out. And then our radius is going to be this number, the square root of 25, since it's r squared. So my radius here is just 5. So just keep that in mind, that it's difficult to remember, but it's huge that we do have to do that square root there. So let's take a look at some examples of these. So this first one, they want to know what's the equation for the circle on the right. My equation is x minus h quantity squared plus y minus k quantity squared equals my radius squared. So first off, let's do the center. The center is super easy. So I'm going to plug in exactly what I see there. So it's x minus negative 1 squared plus y minus 2 squared equals r squared. The negative negative becomes a plus, so I end up with x plus 1 quantity squared. And then I just have to do the distance formula to get my radius squared. So the horizontal distance here, it appears to be 2 units, and the vertical distance is 3 units. So I'm going to do the square root of 2 squared plus 3 squared, which is the square root of 13. And that equals my radius. So if I square it, then I'm going to have my final equation of x plus 1 squared plus y minus 2 squared equals 13. If radical 13 is r, then 13 equals r squared if I square both sides. That's the trickiest part of circles equations, is the radius squared thing. That's definitely tricky. Now, one thing that we can do with this is figure out whether or not a point sits on the circle, whether or not it's part of the circle or if it just misses the mark inside or outside. So looking closely, this tells us that circle Q has a radius of 7 and is centered at the origin, which is the point 0, 0. So if I plug that info into the equation of a circle, I've got x minus 0 squared plus y minus 0 squared equals 7 squared. And just doing some simplification, if it's minus 0, we don't have to keep that. I've got x squared plus y squared equals 49. So that's my equation. And they want to know, does this point lie on that circle? Well, this is x and this is y. You just plug them in. So I've got negative 3 radical 2 squared plus 5 squared equals 49. If the left-hand side equals the right-hand side, then I have a point on my circle. If I do negative 3 radical 2 squared, that gives me 18. And 5 squared gives me 25. When I combine those together, I get 43. And 43 does not equal 49. So no, it does not lie on circle Q. Okay? The other types of problems you'll see is you'll be given an equation of a circle and they want you to graph it. So if I'm looking at this, I've got my negative 3, so I'm going to pull that out and make it a positive 3. I've got a positive 4. I'm going to flip that sign and make it a negative 4. And there's my center. And my radius is square root of 9, which is 3. So I just plot the point 3, negative 4. There's my center. And if my radius is 3, I'm going to go up 3. I'm going to go down 3. I'm going to go to the left 3. And I'm going to go to the right 3. And then I'm just going to connect my dots. They're very difficult to draw properly, so I will not be kind of dinging people for bad drawings. Just be aware they're difficult to draw. Okay, so that's it in regards to the practice that I wanted to show you. Just so you see it, we've got kind of some info here for you. They've got the definition of a circle. They've got the equation of a circle for you, and then they've got a graph with all sorts of stuff marked up in here for you. This is all really, really good information. Circles are different, especially having that radius squared piece. It's something to keep in mind. You could not practice this enough, so I encourage you to do a ton of practice with this, and please make sure to bring in any questions you may have when you come in tomorrow. Have a great night, guys. Bye-bye.